Hello, my name is Frank, and today we are going to study our objective is right triangle trig. So I assume by now you've had the three trigonometric functions explained. There is the sine of an angle, which is the opposite of the hypotenuse. There's the cosine of the angle, which is the adjacent over the hypotenuse. And there's the tangent of the angle, which is the opposite over adjacent. So today we have 6 examples where we're going to find in the first 2 sides, in the second 2 angles, and in the 5th and 6th both a side and 2 angles. So we're going to make sure your calculators are in degree mode, and we're going to round all answers to 2 decimal places. So let's start today. We'll take the first triangle. Ouch! It's hot. It's 90 degrees. I keep forgetting that. Okay, we have a hot triangle, and we have a 73-degree angle and a 12. And this side is the hypotenuse. The side across from the right angle, the hot angle, is the hypotenuse. So let's start off finding either x or y first. So if you were to look at 73 degrees, the opposite side is the x and the hypotenuse, so that would cue you in on using the sine function. So we would say the sine of 73 degrees is equal to the opposite side of x over the hypotenuse. And then if we cross multiply, we would get x is equal to 12 times the sine of 73 degrees. Now, I want to give you time to get your calculator. Once again, your calculator should be in degree mode. And we're going to round everything to 2 decimal places. So we would type in 12, the sine function, which is right next to the x to the minus 1 of 73 degrees. And you should have approximately, that means approximately 11.48. So that should be your first answer for x. Now, once you get x to be approximately 11.48, you have alternatives. You can find this by the Pythagorean theorem y, or you could use basic trig again. Today's lesson's on basic trig. So we're going to use the trigonometric functions. Okay, if we're finding side y, this side y is adjacent to 73 degrees. So we would say the cosine of 73 degrees is your adjacent side y over 12. And if we cross multiply, we'll get y is equal to 12 times the cosine of 73 degrees. And typing that into your calculator, you would have 12, the cosine, which is to the right of the sine key that you just used, of 73, and you'd get approximately 3.51. Now, you put that here, and then just, if you would like to reinforce this, you could say 3.51 squared plus 11.48 squared should equal 12 squared. It'll be very close because we rounded. It may not be exact, but it'll be very, very close. Okay, there's problem 1. Now problem 2 is identical, except we don't use the same trigonometric function. So in this case, notice we're not given the hypotenuse. Remember, the side opposite the 90-degree angle is the hypotenuse. So if we're not given the hypotenuse, we need to start off with the sine or cosine function. So we want to find x. This side is opposite x. X is opposite 35 degrees. So we would say the sine of 35 degrees, excuse me, no, it would be the tangent of 35 degrees. Tangent is the opposite, x, over the adjacent 5. So again, we would use the tangent, the opposite x over the adjacent 5. If we cross multiply, we would get x is equal to 5 tangent of 35 degrees. And typing that into your calculator, you would have 5. The tangent key is to the right of the cosine key that we just used, 35. And we would get approximately 3.50. Now, we need to find side y. Now, let's look at what we have. We have 35 degrees. We have this side, which is your adjacent, which is 5, and we're looking for the hypotenuse. So what we could do is we could introduce the cosine of 35 degrees is equal to your adjacent 5 over your hypotenuse, y. Now, if we cross multiply, we would have y cosine of 35 degrees is equal to 5. And then divide by the cosine of 35 degrees. And these will cross out, divide out, and you'll get y is equal to 5 over the cosine of 35 degrees. And then type that into your calculator. 5 divided by cosine of 35. And you'll get approximately 6.10. Okay, so there would be the 3 sides. We would have y to be approximately 6.10. We have x to be approximately 3.50. All right, now there are the 2 problems predominantly with the sides. Now let's go to this third example where we have 2 sides and all we want to do is find angle A and angle B. Okay, notice it's a hot right triangle, 90 degrees. So to find angle A, we have the opposite and we have the adjacent. Opposite, adjacent. So we could say the tangent of angle A is equal to 12 over 5. Opposite over adjacent. Now, when you want to find an angle, you hit the blue key second and the tangent. So if you hit the second tangent, it'll look like this on most calculators. That's called the inverse tangent or the arctangent. If you then divide 12 over 5, you will get approximately 67.38 degrees. 67.38 degrees for angle A. Okay, now to find angle B, the easiest way to do it is, since we know the 3 angles of a triangle add up to 180, you have 90. So these two angles add up to 90, or they're called complementary. So to get angle B, this means the measure of angle B is approximately 90 degrees minus angle A, because you just found angle A to be 67.38. Now, if you subtract 90 minus 67.38, you will get B to be approximately 22.62 degrees. So really, we used trig to find one angle, and since it's a right triangle, then we could just subtract from 90 to get the complement, or the third angle. So it's really quicker. Okay, example 4. Now, we have a right triangle with 5 and 10. Notice this is the hypotenuse. So we don't have the hypotenuse again. So to find angle A, we're going to say the tangent of A is the opposite side, 10, over the adjacent side of 5. Now, on your calculator, you hit second tan, and that'll appear to be the inverse tangent. And you'll learn to call that possibly the arctangent. So you hit second tan of 10 divided by 5, and you'll get approximately 63.43. So angle A will be approximately 63.43 degrees. Now to find angle B, since angle A and angle B add up to 90, or complementary, you would say the measure of angle B is 90 degrees minus 63.43 degrees, and typing that into your calculator, you would have 90 minus 63.43. You would get approximately 26.57. Okay, so there's your angles in the fourth example. Now, the last two ask you to find both x and angle A and angle B. Now, where do you start is entirely up to you. You can find angle x by the Pythagorean theorem, and you're going to grow to learn that this is a special right triangle, but we'll wait till that time comes. It's entirely up to you. If you want to start off with a trig function and use trig entirely through it, we can. Let's start off with angle A. Now, angle A is the opposite over the hypotenuse in the sine. So you would say the sine of angle A is 6/12. And then you would hit second sine, and that'll appear as the inverse sine of 6/12. And when you type that into your calculator, second sine of 6 divided by 12, you will get 30 degrees. So angle A is exactly 30 degrees. Now, since angle A is 30 degrees, then angle B and A are complementary, so angle B would have to equal 90 degrees minus 30 degrees, or 60 degrees. So B is 60 degrees. Now, how do you want to find x? That's entirely up to you. Now that you know these angles, You could put 30 there, you could put 60 here. Up to you, there's so many options. Well, let's use trig again. Let's just use the 30-degree angle. Since we know that's 30 degrees, this is the adjacent and this is the hypotenuse, and that would open up the cosine of 30 degrees is the adjacent x over the hypotenuse 12. Now we're back to finding a side. So we put a 1 down here and we cross multiply. Now we reach to our calculator. We do not hit second because we are looking for a length, not an angle. So it's 12 cosine of 30, and we get approximately 10.39. So we found both angles and the side. And if you'd like to, you could square to 6, square to 10.39, and see if that adds up to 12 squared. Our last example is, again, find two angles and the side. So let's look at it. Why don't we just start off on angle A to go in order. So we look at angle A, we're given the opposite and the hypotenuse. So that's the sine is opposite over the hypotenuse. Now we're looking for an angle. So we would hit the second sine, and that'll open up the inverse sine of 5 over 8. And typing that into your calculator, second sine of 5 divided by 8, we get angle, in this case A, is approximately 38.68 degrees. Now, we could put that there and we could find angle B by subtracting this from 90 degrees and getting the complement. But just to reinforce that, since this is our last example, let's find angle B using trig now, and then add A and B and see if it is 90. So using angle B, this is the adjacent over the hypotenuse. So we would say the cosine of B is the adjacent over the hypotenuse. Hit second cosine, and that opens up the inverse cosine of 5 over 8. Typing that into your calculator, second cosine, 5 divided by 8, we get approximately 51.32. Now let's just see if we're right. Remember the last ones, we just found one angle and then we subtracted from 90 to get the other one. But if you add these two angles, go ahead, add up 38.68 plus 51.32, you get 90. I guess it's good. Ouch, it's hot, it's 90 degrees. When you're hot, you're hot. We got it. Have a good day.